Okay, welcome back to class. Now, we want to solve additional questions on radioactivity. There are a lot of questions I have put out there under radioactivity. Alright? But there are some of these questions here that were not part of what I solved. So let's solve it again so that you will get adequately prepared under radioactivity. Please, can we have this get column? Okay, now the first question here, let's see. A certain radioisotopes of 23592U, which is uranium, emits 4 alpha particles and 3 beta particles. The mass number and the atomic number of the resulting elements are. So class, this is an uranium, this is 235 and 92. Now, uranium goes on to emit 4 alpha particles. So, let's say this is our element, okay?
Yes.
So let's write out all the emissions. 4 of alpha. Alpha is atomic mass 4, atomic number 2, right? This is alpha, right? Then, what else? 3 beta particles. Alright, this is the beta, either like this or use electron, okay? So beta here is -1 and 0, okay? How many? 3 of it, I think? So let's put our 3 here. Let's put our 3 here. So what do we have now? What will be the resulting here? Resulting element here. So let's do it. So in order to get this one, what we do? We say 235 minus 4 times 4. 4 times 4 is 16. Because it's all alpha particles. Then 3 times 0 0. I think. So what's the answer? That was 2, 3, 5, 16, 9, right? 1 and 2. So 2, 1, 9, right? Yes. Now the next one is atomic number. So 92 minus how many here? 4 times 2, 8. Then this one is -1. 3 times -1, that's minus 3 times -1, that's what? -3, I think. So -3. Do you understand? We are removing all this. Remove this from this, remove this from this. So, but this one is -1, so that will be 3 times -1. Okay? So 3 times -1, what do we have? That's 92 minus 8 plus 3. Minus times minus plus, okay? So what do we have?
87. 87.
Are you sure?
Yes.
You didn't go allow my brain to process it.
No. Maybe 92 minus 8.
Yes, 87, you are correct. So, 87. What is our answer now? The mass number here is what? 219. Atomic number is what? 87. Do we understand that? Alright, so let's move to the next question, please. Okay, let me not clean it. I like clean it, okay. Alright, sorry. You can figure it out. You already know what I did, right? You can figure it out. For those people online, you can pause the video to get your vision. Alright, now, the next one. It said if a radioactive sample initially contains N atom. That's what N atom. The number of atoms that would have disintegrated after 4 half-life is. Now you're looking for the number of atoms that will have left, not the one remaining. There are 2 words. The one remaining after a certain number of half-life, and the one that have left after certain number of what? Half-life. There are 2 different things. Please take note. Okay? So the original mass is what? N. Okay? So how many half-life do we have? 4 half-life. So this is the first. The first half-life will give it what? N over 2. Right? The next half-life will give it what? N over 4. What is N over 4? That is, for every half-life, what is half-life? Half-life is the time it will take for half of the mass to disintegrate, right? So now listen, please, can I have this environment for my class here? Now N, for the next half-life, N over 2. For the next half-life, that's N over 2 over 2, which is N over 4. For the next half-life, that is what? N over 8, right? For the next half-life, which is the last half-life now, N over what? 16. So first half-life, second half-life, third half-life, and fourth half-life. Now, this is what is remaining. This is the regular mass. First half-life, half is the period. Second half-life, half of that half is the period. Third half-life, half of that is the period. Are you getting me? So what is remaining? This is what is remaining. What have left? If this is what is remaining, what have left? This is what is remaining, right? What have left from the original, right? What have left from the original? This is what we had before. This is what is remaining now. How many have left? How will you get that? You just say n minus n over 15. You know what I'm looking for? You said the number of atoms that would have disintegrated. Alright? So that would be what? 15 times n. That's 15 n minus n over what? 15. That would be what? 15 n over 15. Option what? Option D. Are we good? Now the next question. A radioactive sample of initial mass 80 grams has an half-life of 3 years. How many years? 3 years for half-life. Meaning, in 3 years' time, half of the mass will disintegrate. I want the original mass 80. In 3 years' time, 80 will become 40. In another 3 years, 40 will become what? 20. Good. So, they are not asking which of the following rows correctly gives the masses of the substance left at the time specified. So this is the time specified. 3 years, 6 years, 9 years. Remember the half-life is what? 3 years. So it's just like first half-life, second half-life, third half-life, right? So the following row correctly gives the mass of the substance left. What is remaining? Left. Take note of the word. Left. What is remaining? Okay? So, of course, we start with this one. First half-life, 80 to 40. All of them have 40 apart from this one. This one is wrong. Okay? Second half-life, 40 will what? 20. This one have 30 apart from this one. So both of them are wrong, right? Next half-life, 10, I mean, only this one has 10. Okay, this one is 0. Can you see now? So this is our correct answer, A. Did you see how I got there? Alright, I always play back the video to get the full, right? Yes. Now, the next one, 4. A substance with half-life of 5 minutes, right? Has a count rate of 500 after 15 minutes. Count rate, okay? Of 500 after 15 minutes. The count rate at 0 time was, thank you. I love this question. Because this is what kind of mathematics question. How I will solve this question? Watch. They said the half-life, they gave me the half-life. Half-life, which is T superspace 1 over 2 is what? 5 minutes. Right? Let's not do that in 5 minutes, okay? Now the count rate, the count rate is what? 500 after 15 minutes. So after 15 minutes, which is 3 half-life. 3 what? 3 half-life. The count rate after 3 half-life. Let me put it like this. After 3 half-life, the count rate is what? The count rate is what? Is what? 500, I mean. Now, this is how you solve it. Remember, we're looking for the original mass. That's what it's like. The count rate at 0 time. The count rate at 0 time means when the time has not started counting. So that's the original mass. Are you getting me now? So now let's assume that the original mass is n, right? After first half-life, remember the half-life is 15 minutes, I mean.
Yes.
So the half-life is 5 minutes. 5 minutes, another 5 plus another 5, that's 15. 3 half-life, right? Good. So now first half-life will give you what? N over 2. What 2? Second half-life will give you what? N over what? 4. Third half-life will give you what? N over 8, which is the one you have. So you now say N over 8 is equal to 500 count rate. So N is now what? 8 times 5. Can you see how simple it is? Right? So that's what? 4000 count rate. So the original count rate is what? 4000 count rate. Option what is that?
B.
Is this becoming simple?
Yeah.
Alright. Good. So let's take, okay, let me not play it because if I play it now, God will protest. Mr. P, don't do now.
Oh, so physics is must.
Huh?
Physics is boring.
I play it, right? Physics can never be boring. You can't carry your ass. Carry your ass out of the class. This class is meant for online class. It's just that you guys needed to benefit. Okay. So, let's go to next question. What? Number 5, Abby. Okay, fine, right? Fine. Now, a radioactive material has an initial activity of what? 7,000 calories per second. And again. Wow. This are not too much. And an activity of what? 875 pounds per second. After 6 hours, the half-life of the material is. Now, you have an idea of what to do. They just told you that a zero calculate or initial calculate is 7,000. Abi?
Yes.
Then after how many minutes? Sorry, after 6 hours, it became what? 875. So something moved from 7,000 and came down to 875. How many half-life will bring that thing from 7,000 to 8 half-life? 875. That is what the first thing you should know. Before you now determine what is the value of the half-life. So let's take it down to 875. Let's take 7,000 to 875. So first half-life divided by 2. What do you have? 3,500, right? Next half-life divided by 2. What do you have?
1,750.
1,750, right? Next half-life divided by 2. What do you have?
875.
8, 7.
875 naira.
Are you sure?
Yes, sir.
Are you sure?
Very sure.
Okay, so first half-life, second half-life, third half-life. So 3 half-life. And everything happens in the space of what? 6 hours. Therefore, 1 half-life is what?
6 hours.
1 half-life is what? 6 divided by 3. So everything happens in 6 hours. Right? And there are 3 half-lives in that 6 hours. It means that 1 half-life is now what? 6 over 3, which is what? 2 hours. Do you understand me?
Yes.
Okay. The last, okay, number 6. Number 6, are we there?
Reaction.
What type of reaction is represented by the equation?
Now, fusion.
Now, what equation are you seeing here? You are having atomic mass 2, atomic mass 2, give you atomic mass 3, atomic mass 1, atomic mass 5, give you what? Atomic mass 2. Now, what are, sorry, atomic number, give you 2. Now, what are you seeing here? What you are seeing is that two molecules are coming together to form one. Then, you now emitted just what?
Yes.
Neutron.
Energy.
Neutron and energy. Alright, so this is fusion. Fusion. So what is fission? Fission is when one is breaking down. So if this one breaks down to form 1, 2, by what? This is bombardment with this. Not another atom. This is just like neutron, positron, and all that. That would work. That would work. Fission, right? So this is our answer. Fusion. Now the next one. In the radioactive series, are you seeing that? Now, this, right? The particles emitted are respectively. So the first one, what went out? Second one, what went out? And the third one, what went out? That's the question. Alright, let's start. So the first one, you have 235, 235. Nothing went out of the mass number, right?
Yeah.
Now, because 9, 92 and 93. What went out? No. What was added, Abby?
Yes.
That is -1, right? You know? -1. Because whenever delta particle goes out, you are going to add 1 to the atomic number. What I say? You're going to add 1 to what? The atomic number. Right? So we are adding 1 to this atomic number here. Delta particle. So we now have what? 93. Meanwhile, nothing left in what? Atomic mass. Are you with me? So delta particle is just 1. Sorry, delta means. Now the next one. From there to here. What's the atomic mass here? 235. How many here? 231. So what left? 4. Here you have what? 93. Here you have 92. What left? 2. So 4 and 2. That's alpha. The next one. From there to here. 231. Nothing left in the atomic mass. 91, 92. Something was added, which is delta, right? So delta. Delta after delta. Option D. Thank you. We continue with another class.